Today we are going to take a look at changes of state for the matter. What is a change of state? A change of state is a physical change when particles change from one state of matter to another. For example, when water freezes and changes to ice, and when it boils and changes to water vapor. In a physical change, the particles stay the same shape, same size, but their arrangement and energy changes. The change of state normally happens when the particles usually gain or lose energy. Let's now look at temperature, heating and cooling. So what is temperature? Temperature is a measure of kinetic energy in the particles of a substance. When a substance is heated, the particles have more energy and they move faster. Hence, the temperature rises. The image on the screen shows the particle movement when a substance is heated. When a substance gains an energy and its temperature rises, it is called heating. When a substance is cooled, the particles have less energy and they move slower. Hence, the temperature falls. The image on the screen shows the particle movement when the substance is cooled. When a substance loses energy and its temperature falls, it is called cooling. Let's look at change of states more closely. Substance changes from solid to liquid due to a process called melting, and liquid to gas due to a process called boiling as you increase the temperature. It changes from gas back to liquid due to a process called condensation, and liquid back to solid due to a process called freezing as you decrease the temperature. Evaporation is the stage before boiling, and it happens from the top layer of the liquid. Some substances convert from solid to gas directly without becoming a liquid, and vice versa, and this is called sublimation and desublimation respectively. Let's look at each of these state changes in detail. What happens in melting? The particles in a solid are constantly vibrating at their own place. When a solid is heated, the particles in a solid gain kinetic energy and start vibrating with more energy. As the temperature increases, this vibration also increases, and the forces that hold the solid particles together weakens. The regular pattern of the solid breaks down, and the particles slide past each other, and the solid starts to expand. At a certain temperature, called melting point, the particles have enough energy to break free and the solid turns into a liquid. This physical change is called melting. The melting point of a material is the temperature it changes from solid to liquid. What happens in boiling? The particles in a liquid have weak forces of attraction between them. When a liquid is heated, the particles in the liquid gain kinetic energy and start moving faster and faster, and move further and further apart. As the temperature increases, the forces between the liquid particles weaken. At a certain temperature called boiling point, the particles have enough energy to break free and the liquid turns into gas. This physical change is called boiling. The boiling point of a liquid is the temperature at which it rapidly changes from liquid to a gas. If you know the melting point and the boiling point of a substance, you can easily predict its physical state at a given temperature. For example, we know that water freezes at 0 and boils at 100, so we can easily predict that water will be in a liquid state at 25 degrees room temperature. The stronger the forces of attraction between the particles, higher the melting and boiling points of the substance. The particles of a liquid move around with different energies. Some are slower and some faster. The particles on the surface of the liquid have more energy and move fast enough to escape and form a gas. This is called evaporation. At boiling point, the rate of evaporation is maximum. What happens in condensation? The particles in a gas are far apart from each other. When a gas is cooled, the particles lose kinetic energy and move slower and slower. The forces of attraction between the particles increases as they come closer, and they slide over each other. At a certain temperature, the gas will be completely cooled and become a liquid. This physical change is called condensation. When condensation happens, energy is transferred from the substance to the environment. Particles in the substance lose their energy and bonds are formed between them again. What happens in freezing? The particles in a liquid have weak forces of attraction between them. When a liquid is cooled, the particles lose kinetic energy and move slower and slower. The forces of attraction between the particles increases as they come closer, and this holds them together. The particles no longer slide over each other, but make a regular pattern. At a certain temperature, called the freezing point, the liquid is completely cooled and freezes into a solid. This physical change is called freezing. The freezing point of a substance is when liquid changes back into a solid. Temperature of freezing point is the same as that of melting point. That is, the temperature at which solid changes into a liquid when heated is same as the temperature at which the liquid changes back into a solid when cooled. Similarly, temperature of condensation is same as the boiling point. That is, the temperature at which gas changes into a liquid when cooled is same as the temperature at which the liquid changes back into a gas when heated. What happens in sublimation? The particles in a solid are constantly vibrating at their own place. In certain solids, when they are heated, the particles gain kinetic energy and vibrate faster and faster, so much that the forces of attraction between the particles are completely broken. The particles completely break away from the solid and sublime to a gas. Thus, the solid turns into a gas directly without becoming a liquid first. What happens in desublimation? The particles in a gas are far apart from each other. In certain gases, when a gas is cooled, the particles lose their kinetic energy, and it allows the forces of attraction to bring the particles closer and closer, so much that it holds them together. The particles no longer slide over each other, but make a regular pattern, and gas turns into solid. Thus, the gas turns into a solid directly without becoming a liquid first. Now let's summarize what we have learnt so far. Particle vibrations increase during melting, boiling, and sublimation, whereas they decrease during condensation, freezing, and desublimation. Particles gain energy during melting, boiling, and sublimation, whereas they lose energy during condensing, freezing, and desublimation. Forces of attraction decreases during melting, boiling, and sublimation, whereas it increases during condensing, freezing, and desublimation. The particle mass does not change during state changes. Melting point and freezing point temperature of a substance is the same. Condensation point and boiling point temperature of a substance is the same. Sublimation and desublimation occur at the same temperature. Let's look at heating and cooling curves. As you increase the temperature, solids get hotter and hotter. It then starts melting and changes to liquid. As you keep increasing the temperature, liquids get hotter and hotter and evaporation process starts at the top layer. Soon it starts boiling, and it starts changing into a gas. The reverse process happens when you decrease the temperature. I hope you now have good understanding of changes of states.